Fora TV. The world is thinking.
The reason I mention that is that no one, and I say no one, has ever done more for the Institute in terms of the substantive enlargement of its programs and how he has done it, and nonetheless created a situation where we are profitable, and at the same time has kept on top of each of the programs to the point where I guess the staff would wish he were not. He smiles, but that's a fact. I think that the Institute, because of Walter, has developed a level of acceptance, not only domestically, but in the world. We now have programs on global leadership and on almost every substantive issue, from No Child Left Behind to whether you like that one or not. You name it, we've been there because of Walter. And I don't know how else to say it. He has been referred to in the board as the intellectual tsunami and a lot of other things, but it is stunning to believe that he has had the time to do recently the book on Benjamin Franklin and now to do a book on Einstein, and at the same time totally qualitatively improve the Aspen Institute. I don't know how else to say it. We are in gratitude and debt to what he has contributed. Now the country has an opportunity to appreciate the intellectual depth and strength of Walter Isaacson. So we're honored to have him here, and thank you. And ask all the questions you can to embarrass him. Thank you.
Thank you, Burl. You're far too kind, for which I am deeply appreciative. And you're also a bit too modest. Among the programs we have going now is one that Burl has personally taken charge of along with Bill Mayer, which is a Middle East investment initiative that our Middle East Strategy Group is doing. And I know Ambassador Fahmy, who's sitting next to him, from Egypt, has offered a lot of advice. But I think in about 3 weeks, Burl and Bill and some others from the Institute will be going to Ramallah to announce an investment initiative that will allow $25,000 to $100,000 loans to small businesses in Palestine. Oh, $500,000? Yeah, right. Well, good. And that'll be guaranteed by OPIC and funded to some extent by both Israelis, Americans, and Palestinians who are donating to it. And I think it's the type of thing that is great to have the Institute do, and it really couldn't be done without somebody of Burl's caliber. And Burl also serves as the chair of our Trustee Affairs Committee. And Burl, as you know, is a great environmentalist, and so he's recently gotten into recycling. So we're recycling chairmen and trustees so that Burl doesn't have to find new ones. And so I think that's energy efficient of you, and we appreciate it. I would say thanks for having me here, except I realize I'm having myself here. So thanks for coming and hearing me. I figured I'd do a little slideshow because it would make it a little bit more amusing and stuff. And I just really want to talk about Einstein and why I became fascinated with him. Partly it was because when you come to the Aspen Institute or places like that, you realize that there's been a bit of a divide between those of us who are mainly interested in the humanities and history and those who are interested in the sciences. It's a famous divide, of course, that C.P. Snow talked about. But I do believe that it's dangerous to keep talking about the fact that we want our children to learn science and math, so we're going to force feed them in the schools with, rigor and stuff. But we're all going to shy away and say we don't appreciate the wonders of the awe of science. And science is beautiful and it's creative, and it involves the same type of awe that any creative endeavor does, whether it's music or art. And the best way to show that, I thought, was through the person that I've been fascinated with since the early 90s, when became clear at Time magazine that we were going to name him Person of the Century, which is Einstein. And the reason he's so good at bringing the wonders and joy of science is because his science was creative and imaginative. He was not there simply because he was the smartest scientist of the time. In fact, you can make an argument that people like Max Planck or Lorentz or others at the very same time were certainly more academically prepared, certainly had more knowledge, but they didn't have the rebellious spirit, the imagination, or the creativity of Einstein. And that's what made him so special. If there's one thing that Burrell in his 22 years and me in my 5 years at the Aspen Institute has learned, is that smart people are a dime a dozen. It's really hard, though, to find people who are creative and imaginative. And so that's why I wanted to pick Einstein. The good news about Einstein, though, is that for those of us parents, is that Einstein was no Einstein when he was a kid. He was very slow in learning how to talk. The family maid dubbed him de deporte, which means the dopey one in the family. His parents consulted a doctor because he had very slow learning ability. He also was rebellious, causing one headmaster to kick him out of school, another to amuse us by saying Einstein will never amount to much. And he was always defying authority and sort of fighting against the conventional wisdoms and dogma that had been handed down. This, of course, makes Einstein the patron saint of all distracted school kids everywhere. All the T-shirts and posters, and for that matter, books about how he was, a bad school kid, but there's hope for us all, and that sort of thing. But I also think that it was those two qualities that led to what I talk about as his creativity and his imagination. First of all, it was because he was slow in learning how to talk, and this was his own view of it, that he thought and began to wonder about things more slowly than other people did, and he would marvel at mundane things. You and I marvel at mysterious things. He's marveling at space and time, and things that after age 2 or 3, you and I quit marveling about. His dad gives him a compass at age 5, and he says he sits in bed just trembling with excitement, watching the compass for days on end and imagining the force field and trying to picture it, that there are unseen forces in nature that are making that the needle twitch and stuff. And you and I probably remember having a compass as a kid. And you say, hey, cool, wow. And then you move on. It's kind of mundane, But an Einstein, to him, that there was some hidden forces of nature that acted according to laws, just totally astonish him. Second, his slow learning ability teaches him to think in pictures. He does not think verbally. Every single one of his major scientific accomplishments, and I'll try to do them today because I think you should have a sense of the fun of these scientific accomplishments, all come from visual thought experiments. He called them thought experiments. And it's what you and I call daydreaming when we're not Einstein, but he's Einstein, so he gets to call them thought experiments and stuff. Also, the fact that he was just always fighting authority, it becomes his mantra. Foolish faith in authority is the worst enemy of truth. Nobody else would say, maybe Newton's wrong about every single premise Newton started with in the Principia, but he decides to question every premise and stuff. One of the things about Einstein that is not true, unfortunately, it's sad because you kind of want it to be true, is that he flunked math as a kid. If you go back to your office and Google Einstein failed math or Einstein flunked math, you'll get about 66,000 websites, all of which say things like, as everybody knows, Einstein flunked math as a kid, so maybe there's hope for me. There he is as a school kid. He gets 6, which is the highest possible grade in math. He doesn't do too well in languages and other things like that. The reason he does so well in math, in my mind, and I remember talking to Evan Thomas, I see OC there, but I remember talking to Evan. We were walking along the Mississippi River, and we were talking about how they teach math so badly these days. But the reason he does so well in math is what I said before. He thinks in pictures. He sees a mathematical equation, and he realizes that it's just one of the good Lord's brushstrokes to paint something in reality. My daughter Betsy, who most of you know, is 16, and I was doing her math with her about a month ago. She had some algebra. She had these equations. She had to multiply them, and she got one of them wrong on her homework. And she asked me, what I do wrong here? I said, well, just look at it. Clearly, that equation slopes upward, and as you multiply, it's got to slope upward real fast. You're talking about 2x plus y squared and stuff. And she said, what do you mean? I said, well, the equation is just simply a phrase that's used to describe something in nature. You know, she was reading the new translation of the Odyssey at the time for her Latin stuff. And I said, when you see the phrase rosy-fingered dawn, what do? You picture it. You see the rosy-fingered dawn in your mind. Well, when you see a mathematical equation, you should try to picture it and stuff. Well, you know, she said, they never teach us that in school and stuff. Well, Einstein, being slightly smarter than my daughter when he was 16, especially in math, he's looking at some of the great equations called Maxwell's equations that have just been sort of formulated in the late 1800s. Maxwell's equations are a set of equations, they aren't all that hard, that simply say this is the way a light wave looks, an electromagnetic wave to be precise. And they're equations that define an electromagnetic wave or a light wave. And one thing about those equations is they have one thing, they show one thing, which is that the light wave always moves at a constant speed, approximately 186,000 miles per second. So Einstein, as a 16-year-old, being, as I say, more visual in math than they teach kids these days who are 16, decides to try to visualize what it would be like to ride alongside a light beam. He says, okay, I've seen these equations. What would it be like if I tried to catch up with a light beam? I was a kid, and I was riding right alongside it, and I approached the speed of light and got to the speed of light, and I see the waves. Would the waves be stationary next to me? Maxwell's equations don't allow for that. And he's baffled. And he says he walks around and asks his teachers don't know what he's talking about when he asks me. He says he walks around in a state of anxiety, causing his palms to sweat for days on end. As I mentioned, you know, to others, I was remembering the things that were causing my palms to sweat at age 16, and they weren't Maxwell's equations. But, you know, that's why he's Einstein and I'm not. So, like my old friend, Dr. Benjamin Franklin, he runs away from the school in Germany or gets kicked out. It's, you know, the headmaster asks him to leave, and he not only leaves but runs away from Germany, hates the rote learning and the way they try to teach things. So he runs away to Italy and then Switzerland. And he tries to get in to what is the second best college in Zurich, the Zurich Polytech. And he fails his entrance exams, which is reassuring. But the following year, he finally does get admitted to the Zurich Polytech. And he does well enough as a physics student there. But being rebellious, defiant of authority, he's able to piss off all three of the major professors there. Hermann Minkowski, the math professor. Einstein doesn't even think he needs to know the math that well. He just wants to be a physicist. He doesn't realize that the math will lead him to his physical theories. He figures that out later. So he doesn't even attend most of the classes, and he gets a friend, Marcel Grossman, to take notes for him in math class, causing Hermann Minkowski to write on one of the reports that Einstein is a lazy dog, which I loved. Heinrich Weber. He teaches physics, but he doesn't even really teach Maxwell's equations. He thinks they're kind of newfangled and stuff. So he basically doesn't even get up that far in the teaching of physics. So Einstein is contemptuous, starts calling him Herr Weber instead of Herr Professor, at which point Weber refuses to speak to him. And finally, there's Pernay, the laboratory instructor. Einstein was never a very good experimentalist, which is why he had to become a theorist. And so at one point, he throws away the instruction sheet for the lab they're doing, and it causes him to explode one of the devices, and Pernay puts him on academic probation. Thus it is that Einstein is the only graduate in his class from the Zurich Polytech who cannot get a job. He can't get a job as an assistant professor. He can't get a job as a teaching fellow. He can't get a job as a doctoral fellow, nothing. He applies 17 different places to teach high school in Switzerland and Germany, and he's rejected in all 17. One of them, he even applies to teach math and says, I'll also teach physics as well, and he sends in all of his stuff, and he's not even put on the short list of the 3 candidates that they consider to teach high school. So the guy doesn't have a job. He's wandering around sort of tutoring, puts ads in the paper saying trial lessons free. He gets one student that he tutors. And being Einstein, He becomes friends with this guy, and after the second time, he says, you don't need to pay me anymore. Let's just get together and we'll discuss it. He becomes one of Einstein's best friends. Finally, Marcel Grossman, the other really close friend who had taken notes in math class, gets Einstein a job. Through his connections and family connections, he gets Einstein a job as a third-class patent clerk at the Swiss Patent Office in Bern, an examiner of patent applications, sitting on a stool on the third floor of the Post and Telegraph building. Now, lest we feel sorry for Einstein, I actually believe, and I try to show in the chapter in the book, that this was a godsend for Einstein. That being an acolyte in the academy, with all due respect to those of you like Ben who are from, the American Council of Higher Education and stuff in this building, and being a junior professor who has to, please and, honor senior professors and do their research, he would not have been good at that, and it would have made him teach received dogma. Secondly, he has a wonderful boss at the patent office who encourages his own instincts to question every premise. An application comes in, just question every underlying premise. Thirdly, the patents that he's looking at are electrical devices. And the main thing he's looking at are devices people have come up with, or proposals people have come up with, to synchronize clocks. Switzerland has just at that time gone on standard time zones. And the Swiss, being Swiss, are rather obsessive about making sure that the clocks are synchronized, so that when it's 7 o'clock on the Bern clock tower, it's 7 o'clock on the Zurich clock tower and everything else. And right outside of his building is the famous Bern clock tower. Those of you who know it, it's 11th century clock tower with the cuckoo stuff that comes out on the hour. The trains rushing underneath it, and that's the standard time for all of Switzerland. The trains rush below it and go into the station where there are all the synchronized clocks. The one thing that all these patent applications have in common is that they use a signal, of course, to synchronize a clock. And what do the signals have in common? They travel at the speed of light. They're either telegraph signals, electrical signals, radio signals, whatever. They travel at the speed of light. So Einstein's looking at trains rushing into the station. He's looking at, light beams that are synchronizing clocks. He's questioning every premise. And he's thinking of that experiment he did, a thought experiment, as a 16-year-old, about what if you catch up with the light beam. And he's sort of confused. He wants to try to figure it out. So in his spare time, he's writing papers. He was working 6 days a week at the patent office, but Haller's nice enough. He lets him, then sort of turns a blind eye while Einstein's writing physics papers and hiding them in the drawer of his desk and stuff. And in 1905, there he is trying to figure all this out. And fortunately, we have a letter, because one of Einstein, this is the guy who he offered tutoring lessons to and decided instead to become friends with. And this is Conrad Habicht, another engineer who worked there. They form what's called the Olympia Academy, which means it's a drinking club. They go out and drink and talk and smoke and whatever, so they're friends. But fortunately, Conrad leaves the first week of May to go away to try to finish his dissertation. Unfortunately, Conrad's a ne'er-do-well and never writes back. So Einstein writes him a letter in May of 1905 that is typical Einstein impudent letter. It says, "You frozen whale, you canned piece of soul, you have not sent me your dissertation as you promised, and so I'm going to write you this letter that's filled with inconsequential babble. But if you send me your dissertation, I promise you 4 papers I've been working on in return." It's only when you get to the second paragraph that you realize, oh, this is the most important tidings in the history of science in this impudent letter. And the letter goes on to say, the first deals with energy and radiation and is quite revolutionary. Well, indeed it is. It's the paper that says light is not just a wave, it's a particle called a quanta. And this is the foundation of quantum theory, and it's the most revolutionary theory in all of, probably in all of physics in a way. He says the second paper determines the true size of atoms and molecules. At the time, most professors in the academy did not truly believe that atoms and molecules existed, but Einstein nevertheless uses this as the paper to try to get, on his third attempt, to get a doctoral dissertation accepted, because he knows it's the simplest of all of his papers. He says the third deals with Brownian motion, which proves, using the atoms and molecule theory, why little particles jiggle in water under a microscope. And then he says the fourth paper is only a rough draft at this point, but it involves a modification of the theory of space and time. So you say, whoa, that's not inconsequential babble. And obviously, it's special relativity. What he does not tell Conrad, because he hasn't quite figured it out, as soon as he finishes that rough draft of the fourth paper, he goes on vacation for a week and comes up with a new thought. That's just a little addendum, that if he's right about the quanta and if he's right about the theory of special relativity, then there's a relationship between energy and mass that's related by the speed of light. So he comes up with what is the most famous equation in all of physics in a little 3-page addendum he writes to his fourth paper, E equals mc squared. Now, relativity is actually a pretty simple concept. And he does it all in pictures. I'm going to do it all in pictures. The paper he writes on relativity has no math that a high school student couldn't understand. And all it is thought pictures he does. And the simple part of the principle of relativity is something Galileo knew, which is if two people are in motion like that, gliding along at constant velocity, neither one, all the laws of physics apply equally to both of them. And one could say, I'm at rest, you're moving. The other could say, you're moving, I'm at rest. You can't really tell who's moving. The motion is just relative. Galileo does it famously in Discourse on Two World Systems, where he talks about the hold of a ship. If you block out all the windows and it's moving gently along in the ocean at a constant velocity, you can release butterflies. They fly around. You can drop pebbles in water. The ripples come out. You can talk. You can bounce a ball. Anything you can do as if you were on shore at rest. And you can't even tell that you're not at rest if every window is blocked out. That's called the principle of relativity. And it's simply that, you may think you're here at rest, and you see an airplane there, and you say, that's moving, I'm at rest. No, you're sitting here, you're moving 36,000 miles per hour just around the sun as the Earth moves, and the sun is moving around the galaxy, and the Earth is rotating, and the person on the plane, if it's sort of gliding along without bumping or anything, they can say, I'm at rest, and the Earth is rotating beneath me. No way you could say anybody's right, anybody's wrong. The problem with the theory of relativity, or the principle of relativity, is that it seems to conflict with Maxwell's equations. Because if you catch up with a light beam, it would look differently. If you're traveling at the speed of light, things would look differently. If you're rushing towards a train's headlight, it would seem like the light would come at you faster than if you're rushing away from the headlight. So Einstein, along with every other great physicist of the time, is baffled. Michelson and Morley keeps proving that the speed of light is constant, but they're baffled because it seems to be incompatible. Einstein says it's incompatible. Once again, he talks about walking around for weeks on end in a state of high anxiety because the principle of relativity seems incompatible with the constancy of the speed of light. And then he's walking with Michele Besso, another one of the close friends, another guy he hangs out with, another ne'er-do-well who got a job in the patent office. And they're walking one weekend, looking at a distant clock tower and stuff, and Einstein says, I've got it. And he calls it the step. He doesn't explain it to Michele till the next morning. Comes into work the next morning and says, here it is, I've got it, I've made the leap, or what Einstein calls the step. And the step he does in totally visual ways. And he says, and here's a guy, synchronizing clocks and stuff. He says, what does it mean when we say two things are synchronous, that they're synchronized? What does it mean to say something happened at the same time? If you're a patent officer, you have to have an operational definition. For them, one operational definition that works is if something happens way over there and something happens way, way over there, and if you're standing exactly halfway in between and the light gets to you at the exact same time, you say they were simultaneous. That's an operational definition of being simultaneous. And now, Einstein says, imagine a fast-moving train. He does this as a line drawing in one of his papers. A fast-moving train going in this direction. Lightning strikes it at both ends. There's a guy standing halfway there in the platform, right? the light gets to him at the exact same time from the two strikes. So he says they're simultaneous. That's pretty simple. There's a woman on the train. She's dashing forward. By the time the light reaches, she's a little bit further forward. I mean, just a nanosecond. I mean, the speed of light, so you don't notice this, but this is just a thought experiment. She's a little bit further along, so the lightning strike in front, the light from that gets to her first, and she says it looks like the one in front happened first. What does the principle of relativity tell us? Neither one is right, neither one is wrong. It's all relative. Whether those two strikes are simultaneous is relative, depending on your state of motion. Now, it's not that easy, and don't worry, because when he did this in 1905, it takes about 10 years for the greatest physicists in Europe to sort of capture it. But this is all just an imaginative, creative, rebellious thought experiment that says if you're in a state of motion different from somebody else, you'll have a different definition of simultaneity. And then he says, if that's the case, you'll also have a different definition of time. Because he says, what do we mean by time? And this is in the paper. He says, what we mean by time is we look at our watch and the hand hits 7 when the train gets to the station and stuff. So it's just a definition of simultaneity affects a definition of time. Anyway, that is all that is at the heart of special relativity. And it seems either totally baffling and philosophical or totally brilliant, and it takes a while for people to figure out which. Helping him with that paper is a really interesting woman, Mileva Maric. Mileva Maric was a physics student, a woman in Serbia, brooding, melancholy, girl from Serbia, and who overcomes most but not all of the obstacles facing women way back then in Serbia in physics or at Harvard now or whenever it is. But her father is an army officer and forces the Zagreb Academy, which of course takes no women, to take her and teach her. And she becomes, as you can probably guess, the only woman at the Zurich Polytech in physics. And, as you can probably guess, they fall madly in love. Absolutely torrentially in love. And we have these new letters that I got access to last year. They're in the book. They're almost, hard to say in public. I mean, about pillows being on fire and all this love. They are madly in love. They take, as students, they decide to escape school and go to Lake Como. All of you have been there probably, and the other places besides Aspen that are pretty. They hike around Lake Como in the snow. She gets pregnant. They have an illegitimate daughter named Lazurl. They put the daughter up for adoption. In the book, I explore one of the great mysteries of history, which is whatever happened to Einstein's daughter. They can't get married, partly because of family problems. He's Jewish. She's Serbian Orthodox Christian. But also because he can't get a job. It's finally in 1905... in 1902, when he does get that job in the patent office, that very week, they get married. Their parents don't even come to the ceremony. It's at the Bern registry. Only the people you saw on the screen, Conrad, Michele Besso, Grossman, Maurice Sullivan, all his friends show up. They have 2 sons, Hans Albert and Edward. But it's a very, very tempestuous relationship. Very tough relationship, and the letters get brutal after a while. And what eventually happens is they decide they want a divorce, but he can't afford a divorce. He's still, even after he's written those 1905 papers, he's still being rejected for jobs teaching high school. So if you didn't get special relativity when I showed it to you, look, no university gave him a job until 1909 is when he gets his first assistant. So it's 4 years. He has no money. So he says to her, here's the deal. One of these days, one of those papers will win the Nobel Prize. If you give me a divorce, I'll give you the money. She consults. She's a physicist. She consults with other scientists. She consults with a lawyer. She draws up a contract, and she takes the bet. She's smart, sort of. It's not until 1922, if you were feeling bad you didn't get the lightning in the trains thing, it's not until 1922 that they give him the Nobel Prize. They announce it. And by the way, they don't give it to him from relativity. They're still a little baffled by it. And she gets the money and she buys 3 apartment buildings in Zurich. At the time, by, he finally gets a job. He goes to Berlin. The marriage dissolves. And 1915 is an awesome period. And this is where some of the main batch of the new letters that have come out are from that period. And World War I is broken out. Einstein is very sick. He can't get food. I mean, he's not the type of person who wants to wait in line starting at 6 in the morning for bread. Finally, he has a cousin who starts nursing him back to health and feeding him. He ends up marrying the cousin, but it's causing a great rift with Mileva and the two boys, who are 8 and 11 by this point. And you realize how all too human and sad this is. I mean, he's written these horrible letters about, to Mileva about, contracts they should have on what she would do if she wanted to get back with him. The kids are being used as a pawn. At one point, November 1915, Mileva, I think, has Hans Albert writes a letter, and it seems from the phrasing that it's prompted by his mother, because it says, Mom says that you won't come visit us for Christmas. I mean, the border is closed because of the war, but he was trying to get down. And that you have forgotten about us because you're too busy with your work. But at least she bought us some skis to make us happy. They cost 70 francs. And she says, I should write to you because you will have to pay for them. I mean, you think, whoa, this is real human drama. This is what happens. And he writes a furious letter back, refusing to pay for the skis. But the interesting thing is he is writing that letter on the day he's trying to give his first lecture at the Prussian Academy on the greatest theory in the history of science, which is the general theory of relativity. And he still doesn't have the general theory right. He's got 4 lectures, and he just has the beginning. I mean, he has the theory right, but he hasn't gotten the math cleaned up yet. He is working all night on these lectures and struggling with his family and struggling with the war and stuff. What is the general theory? There's a problem with the special theory. In fact, there are 2 problems. It's called the special theory because it only involves constant velocity motion. Galileo's ship, you're in constant velocity, but if all of a sudden the ship is speeding up or you're in a train that's slamming on its brakes or turning, you're in real motion. It's not all relative then. It seems different if you're accelerating. In the laws of physics seem different. You bounce a ball, it rolls away. You pour coffee, it sloshes out if you're accelerating. Secondly, he's overthrown already. This is Newton. Einstein has overthrown the 2 of the 3 fundamental things that were premises of Newton. One, in the Principia, saying that time marches on at its steady pace, second by second, irrespective of any of our observations of it. Einstein says no. Secondly, that space is absolute. Einstein throws it out. Still, Newton has a theory of gravity that says gravity is just the attraction between 2 big old objects, or 2 small objects for that matter, and it happens instantly at great distances. It happens where the sun instantly attracts the Earth, and the Earth attracts the moon. And Einstein's special theory says nothing can travel faster than the speed of light. No action can happen faster than the speed of light. No information can even go faster than the speed of light. So that conflicts with Newton's theory of gravity. So what does Einstein do? Once again, a simple thought experiment. Totally simple thought experiment. Imagine, he says, you're in an enclosed chamber, say an elevator. And say the elevator, enclosed chamber, no windows, is sitting on the surface of the Earth in a gravitational field. What do you feel? You feel your feet being pressed to the floor, just like I feel now. You take something out of your pocket and you drop it. What happens? It falls at an accelerated rate, just as Galileo said. Boom. Now imagine you're in an enclosed chamber, exact same type of chamber, but you're in deep outer space where there's no gravity, but it's accelerating upward. What do you feel? You feel your feet pressed to the floor. You take an object out of your pocket, drop it, it falls at an accelerated rate. What Einstein says is, he calls it the equivalence principle. Gravity is equivalent to acceleration. All the effects you'd feel, you wouldn't know whether you were in a gravitational field or accelerating upward. It's beautiful, the way he writes it, even looking out and seeing the rope hanging there, and you say, well, I can't tell whether the rope's pulling me up or whether it's keeping me in a gravitational field. Everything is equivalent, no experiment you can do to tell the difference between them. Now, you know what? It ain't that hard, even though nobody had figured it out. Galileo should have figured it out. Newton had figured it out. Even in high school, they teach us that inertial mass is the same as gravitational mass, right? I don't know if you remember that. Inertial mass is how much force you got to push on something to make it accelerate. Gravitational mass determines how much it weighs when it's in the gravitational field. But somehow, ever since Galileo, they knew that these two things were equivalent, that gravitational mass always equaled inertial mass. But they didn't know why. Nobody ever understood the theory why. And the theory is just as simple as can be, which is gravity is equivalent to acceleration, which is why it happens. So what Einstein does is he comes up with a totally different theory of gravity, which is that gravity is simply the curving of space. Now, once again, slightly difficult, but this is creative, imaginative leap. And he does it, once again, thinking in thought pictures, not thinking in, complicated scientific terms or formulas. He says, imagine a fabric. And in this case, let's say that's a trampoline fabric. And imagine that you roll a big bowling ball on the trampoline fabric. What happens? It curves that two-dimensional fabric. What happens if you roll some billiard balls behind it? What do? They curve towards the bowling ball. Why? Not because the bowling ball has some mysterious attraction taking the billiard balls to it, but because they roll down towards the bowling ball. They're curved towards it as the bowling ball curves the fabric of the trampoline. The billiard balls roll on down into the indentation, into the curve or the warping that the bowling ball makes in the fabric. That's, even I think most of us can get that one. You can picture, I see why the balls would roll there, because it curves the fabric downward that way. And that's easy for even us to do. If you're Einstein, you can actually picture it in 3 dimensions, where an object not only curves the 2 dimensions of the fabric, but curves all 3 dimensions of space. And if you're truly an Einstein, you can imagine it in 4 dimensions, because what Einstein's special theory tells us is that space and time are really woven together in a 4-dimensional fabric. And so, as Einstein says, gravity is the warping of the 4 dimensions of space-time. Most people they're not quite sure. I mean, you kind of see it, but you think, what's this, philosophy? I don't get it. How do we know? And worse yet, in Germany, anti-Semitism is rising up. And they start labeling this Jewish science, because it's not like Deutsch physics, German physics, that's concrete and grounded in reality. It's all thought experiments. It's all philosophy. It's not real. So Einstein proposes a real-world test. He says, look, and you don't even have to worry too much about this, but if you're in something that's accelerating upward and a light beam comes in, by the time the light beam crosses the chamber, it'll be a little bit lower on the next wall because the chamber's gone up. And if it's accelerating upward, there'll be a curve. What does that mean from the property of equivalence? It means that gravity will curve a light beam, right? Now, people aren't sure he's right. But even if you think E equals mc squared, that energy has mass, gravity curving a light beam. Something everybody can get their minds around, but they don't know how to do it. And he says, okay, here's how you test it, and he even does the math for it. He says, the light from a distant star or anything, as it passes right next to the sun's gravitational field, I've calculated it, will bend starlight by 1.7 arc seconds. You can test it. Now, it ain't that easy to test because you can't look right at the sun and see the stars behind. So as World War II is ending, a British Quaker decides, who's a pacifist, to prove right, he hopes, the theory of a German Jewish pacifist to overcome, showing that science can triumph over politics. World War I, sorry. So it's 1919. War is just ending in the end of 1918. They send an expedition to an island off the coast of Africa and one off the coast and place in Brazil where there's going to be a total eclipse of the sun. So you'll be able to see the stars coming behind it. And they do all the photographs and stuff. They know where the stars are supposed to be. The eclipse happens. It's Sir Arthur Eddington. It's this great moment. There's sort of clouds. He's all worried about it. But he photographs where the stars are right behind as the starlight comes right next to the sun, which you can only see for the 3.5 minutes of the total solar eclipse. They bring all the photographic plates back to London. It takes 4 months to compare the plates, to look at where the stars are supposed to be, to look at where they are in the photographic plates, to compare the two from South America and off the coast of Africa. And then Sir Arthur Eddington goes, they call a meeting of the Royal Academy, a grand meeting. Everybody knows it's an exciting event. I mean, Bertrand, all sorts of philosophers come down. The place is packed in Piccadilly. And Sir Arthur Eddington and J.J. Thomson, the discoverer of the electron, are presiding. He looks up at the portrait of Sir Isaac Newton, the first president of the Royal Academy, and says, "Forgive us, Sir Isaac, your universe has been overturned," proving that gravity bends light. Einstein's back in Germany because he can't go on over. He's waiting for the results, gets a telegram telling him that he's been proven right by Eddington's observations. He shows it to a graduate student who's there, and she says, "You must be, thrilled." And he said, "No, I was always confident." He said, "Yes, but what would you have felt had it turned out the other way?" Einstein said, "I would have felt sorry for the good Lord because the theory is correct." Now, for journalists in the room, Mr. Kaiser and others, this was in the days when newspapers knew how to cover science and when the New York Times knew how to write great headlines. They have sent somebody to cover this event. Of course, they haven't been able to send their science correspondent because getting them over there right at that time is bad. But they have Henry Crouch, who is their golfing correspondent because there's a golf match happening in England. So he goes to the meeting of the Royal Academy, has to spend 2 separate sessions with Eddington, getting Eddington to explain it over and over again. But here is the headline that makes Einstein world famous and proves that he was right. "Lights all askew in the heavens, men of science more or less agog. Over result of eclipse observation, Einstein theory triumphs. Stars not where they seemed or were calculated to be, but nobody need worry." The New Yorker starts doing, everybody trying to figure out the theory of relativity. It's suddenly a super celebrity, and it's the age of celebrity. Right at the end of World War I, there's this hungering for celebrity, there's a mass media, and you have a genial German theorist with a wild halo of hair, piercing eyes, talking in quips and quotes, and describing his theories with beautiful pictures and lightning and strength. And his theories have that perfect combination of like we're always saying, and wow, like we all kind of say, like gravity bends light, energy and mass equals mc squared, time slows down as you speed up. And even the 16-year-old's experiment in his mind about catching up with the light beam, he explains it, which is, as you're chasing a light beam and a light wave, as you get closer and closer to catching up with it, no matter how close you get to the speed of that light wave will still travel at 186,000 miles per second, just like Maxwell's equations say, at least for you. But time will slow down for you. And so time slows down, solves the light beam thing. So once again, he's become this great celebrity, and because of the anti-Semitism that he felt, he throws himself into various forms of politics, one of which is supporting Jewish scholars and refugees, supporting Hebrew University in Jerusalem, and coming with Chaim Weizmann to America right after the eclipse observations for a tour that would have astonished, visiting rock stars or something. 10,000 people are there to meet them late at night at the foot of the Battery in Manhattan when the boat comes in. Weizmann actually gets off the boat first, and they ask Weizmann the question they ask everybody who meets Einstein, which is, do you understand the theory of relativity? Weizmann's wonderful answer is, on the journey over, Professor Einstein explained it to me many, many times, and by the time we got here, I was convinced that he understood it. He is paraded all over everywhere he goes. There are parades and open cars for a theoretical physicist. This is not just... And only people like you will understand this. When he's brought down to Washington, the Senate of the United States decides to debate whether relativity theory is true or not. Senator John Rankin of Mississippi in the opposition, and the great Boyce Penrose of Missouri in support. They bring him to see President Harding on the steps of the in the lawn of the White House. And of course, they asked Harding the question, do you understand relativity? And back then, politicians were reasonably honest, so Harding said no. And so they said, Einstein said that was okay. He didn't understand the theory of normalcy, which was Harding's political platform. He goes to, I don't know if you've ever been to it, but the great Swedenborg statue of Einstein reclining, I think it's 22nd in Constitution Avenue, the National Academy of Sciences. A beautiful, beautiful statue of him, larger than life there. And that commemorates on the same trip, he went to dinner there where various scientists were honored, not just Einstein. And at one point, there was a long lecture during the evening by somebody who I think had been studying ground slugs. And Einstein turns to the physicist from Denmark next to him and says, I've just developed a new theory of eternity. But anyway, it was all these quips that make him totally beloved and a great thing. When he finally meets Charlie Chaplin, the person who is perhaps the only other person in his orbit as a celebrity, they go to the premiere of City Lights together. Huge crowds turn out to see the two of them, and Chaplin says they cheer you because they don't understand you. They cheer me because they understand me. Anyway, it's truly amazing. But something interesting happens at that point. He wins the Nobel Prize, as I say, but he wins it not for special relativity or general relativity. He wins it for an aspect of the quantum theory paper on the photoelectric effect, because they're still a little bit baffled by all of this. And what's interesting about that is at that point, Einstein is turning against quantum mechanics. Quantum mechanics has at its core an uncertainty, the Heisenberg uncertainty principle, that it depends on your observation what the position or the velocity of a particle will be, that things are probabilities, as Niels Bohr said, as opposed to certainties. And Einstein, who's sort of done all those rebellious types of thoughts over the years on space and time and gravity, suddenly is becoming rather conservative. And especially because he believes in certainties, in strict causality. And what he says over and over again, very famously, perhaps his most famous quote, I cannot believe that God plays dice with the universe, meaning he doesn't believe that there are uncertainties. He believes in strict causal laws. He says it over and over again. Finally, at the 1927 Solvay conference, when Einstein says it, Niels Bohr comes back at him with, Einstein, please quit telling God what to do. Which raises the question of God, which surprised me somewhat. Because he uses the phrase, God, I'd feel sorry for the good Lord, subtle as a Lord, but malicious is not, God would not play dice. And people think, well, maybe it's a figure of speech. And of course, in the 20s in Berlin in the early 30s, a very secular period, everybody assumed he was an atheist and he was just using that as a figure of speech. And repeatedly, he says no. Famous dinner party I start the Einstein and God chapter with, a dinner party in Berlin, where he says to the hostess and everybody else, no. I believe in God. I have a very deep faith. My deep faith comes from the awe and humility that I have studying the universe. He did not necessarily believe in a personal God who you could pray to, intercede in our lives and give us a snow day if we hadn't done our homework. But he believes in a God, as he said, there's a spirit manifest in the laws of the universe, in the face of which we must be awed and humbled. To me, that is the closest feeling I can have to a cosmic religion, and to me that explains my faith in a creator and a faith in God. And people keep questioning him. A young child questions. He says, do you pray? He says, we're like a very young child who enters a library and sees the books. And the child knows, is dimly aware, that somebody must have written the books and that the books have been ordered. And as we try to understand how that began and what created it, that, to me, is a sense of cosmic religion that informs me. I always ask myself when I do a theory, he says, whether God would have created it this way and whether God would have made the laws of the universe this way. So he's deeply religious and keeps saying, as fighting with atheists who keep, like Sigmund Freud and Bertrand Russell and others, he said, the fanatical atheists always try to use me. I worry about them more than about the fanatical religious zealots. because they too are zealots in their own way. And so he's there in this notion of an impersonal God, and it doesn't quite satisfy people. They don't quite know what to make of it. The cardinal in Boston still does a sermon, famous sermon, after Einstein writes an article called Science and Religion for the New York Times, saying, well, it still smacks of atheism to me and relativism. And so Rabbi Goldstein, Morris Goldstein, who was the head of the Reform movement in New York at the time, sends a telegram to Einstein saying, Einstein, please answer yes or no. Do you believe in God? 25 words or less, answer paid. And Einstein doesn't even use up all the 25 words. He says, I believe in Spinoza's God, whose spirit is manifest in the beauty and the harmony of the spheres. So it's hard for people to understand in a way, but I don't think it's that hard. I think we all have wrestled with this. Benjamin Franklin comes out in sort of this deist concept of God. Thomas Jefferson. And whatever our beliefs are, it's interesting to see him wrestle with it. And I think even if a cardinal and a rabbi can't understand it, most of us can understand how somebody would be wrestling with such a deist position. Whoops. There we go. He also has been a pacifist. A militant pacifist, Einstein, War Resisters League and stuff. But unlike some people in this town, he really believed there should be a connection between factual evidence and your general theories and your ideology. So when the evidence changes, he changes his theories. And Hitler comes to power, and he immediately rejects pacifism and says, this is evil, and if I were a young man, I would join the army. Surprises at his fellow pacifists, but he even goes so far when he meets with his friend Leo Szilard, who he had once invented a noiseless refrigerator with that didn't work very well, proving Einstein was never very good in the laboratory. But his old friend Szilard had come up with the notion of a chain reaction, basically putting E equals mc squared into practice. And they meet at the end of Lug Island. And Szilard explains it to him, and Einstein writes what may be one of the most significant letters ever written by a scientist to a political leader, the famous letter to F.D. Roosevelt, President of the United States, from Albert Einstein and Peconic, some recent work, et cetera, et cetera. This new phenomenon could lead to the construction of bombs. And so he basically says we have to get to work on an atom bomb project. Franklin Roosevelt gets the letter, says this demands action. It's a very famous scene, starts the Manhattan Project. Ironically, because he had been such a pacifist, J. Edgar Hoover had been compiling a dossier on Einstein that eventually reached 1,400 documents of all of his pacifist activities. So he was not giving a security clearance to know about the Manhattan Project or to work on it. It did make Einstein, though, when the bomb comes off, it happens in 1945, he's still the guy in the public mind. The equals mc squared is sort of father of the bomb, he is called. And so he becomes not a pacifist again, but a believer in arms control, a strong believer in arms control. Secondly, because of his problems with J. Edgar Hoover, he is a strong believer in free speech, free thought, and free action, fighting McCarthyism, fighting for J. Robert Oppenheimer, his colleague at the Institute of Advanced Studies, where Einstein then worked, and saying that the whole point of the whole lessons of this century are people who had fled oppression in order to go to lands of freedom, and that it was the lands of freedom where people had free thought and free expression that were going to be the most rebellious at times, but also because of that the most creative and most imaginative, which is basically the great description of Einstein. And so he's very much in the forefront of those fighting McCarthyism, very much in the forefront of those trying to get nuclear arms control, and that's how he spends the remaining years of his life. He also is in the forefront of trying to get a unified field theory. What does that mean? He's trying real hard to get that theory that will overcome quantum mechanics, that will show quantum mechanics is incomplete, that there aren't uncertainties in the world. And this, to me, was a particularly interesting part of the last section of the book, which is why does Albert Einstein, the most rebellious, impudent, impertinent guy who's questioning every premise, doesn't believe in any received dogma, why does he become a conservative at age 50 or so? Why does he spin into a defensive crouch defending the classical order of physics, classical determinism, when experiment after experiment is showing that quantum mechanics is correct? And the people doing quantum mechanics, Heisenberg and Bohr and others. They're like Einstein. They're thinking out of the box rebelliously. They're the young Turks, and he's become. And one of my favorite lines is, having early in life said, "Long live impudence, my guardian angel," when they ask him about why he has become a resistor of the new in physics, he says, "To punish me for my contempt for authority, fate made me an authority myself." So maybe that's at age 50 or so, or 60, we watch it happening to us and see it. Anyway, he is, at the very end of his life, he's still working on all the things he loved. Ben Gurion, when Chaim Weizmann dies, Ben Gurion offers Einstein the presidency of the State of Israel. Smartly, Einstein says no. I mean, he would be a horrible president. But he does agree to give the Independence Day anniversary speech in 1955 for the State of Israel on one condition. He wants to make it a speech not about Israel, but about world peace and why we have to all work together, not just Arabs and Jews, but all of us in the nuclear age work together. But right before he was to give the speech, before he started writing it, he's brought to Princeton Hospital. He had an aneurysm. It burst. It's hemorrhaging. They know he's going to die. He's in the hospital, and late that afternoon, he revives slightly, and he reaches for a piece of paper, and he writes the first sentence of what would be his speech if he were to have lived to give it. And it's, "I speak to you today, not just as an American citizen and not just as a Jew, but as a human being." He wants to make that point, that we all have to work together. And then the pain becomes too great. He puts the papers aside, but really a few minutes later, he reaches over again, and instead of going back to the speech for 20 years, he'd been trying to get the unified field theory, the thing that would explain it all. So he reaches over, and he does one last page of calculations, one last page of equations that's supposed to get us, on the unified field theory. Once again, still having problems with the math, crossing it out, even getting 5/9 wrong, crossing it out, and finally having it be 2/3. But line after line until finally the final line where it kind of trails off and doesn't end as he writes it, trying to get himself and the rest of us just one step closer to the spirit manifest in the laws of the universe. And then he goes to sleep for the last time. So that's how a very impertinent, very rebellious, but unbelievably creative third-class patent clerk became the mind reader of the creator of the cosmos and the locksmith of the mysteries of the atom and the universe. Thank you all.